Hello everyone, this is Judith and today I'll walk you step by step through how to set up a secure virtual private cloud in AWS. I'll not only show you how to do it, but I'll also explain why each step matters so you understand the bigger picture of everything. So what is a VPC? A VPC, which stands for a virtual private cloud, is like your own private data that is inside AWS. So think of AWS as a giant city where thousands of businesses rent space. So a VPC is your own fenced neighborhood in that city, is isolated, is secure, and is under your full control. So inside your VPC, you decide which servers live there. So the servers there are your EC2 instances. So you also decide how the servers connect to each other, whether they are public or private. So to create a VPC, first log into AWS, search for VPC, click on VPC. So it will take you to the VPC dashboard where you create a VPC. So here you click create VPC, select VPC only. So you give the VPC a name, let's say VPC admin, VPC admin. You scroll down. So for the IPv4 CIDR block range here, I'll set it to 192. 192. For the IPv6 CIDR block range here, I'll leave it at default since I don't need it right now. Next, I proceed to create VPC. So VPC successfully created. So next is the subnet. A subnet is like dividing your fenced neighborhood into streets where you have the public subnet that has the houses facing the main road, and also you have the private subnet that has the houses hidden behind with no direct access on the street. Click on subnet here to create a subnet. So here I'm going to create a public subnet and a private subnet. So once you clicked on subnet here, you proceed to click create subnet. So here you select the VPC that was created, you click on the drop down and select the VPC admin here. So you scroll down to the subnet setting. Here we have the subnet name. You give the subnet a name. So we'll first create a public subnet. Public subnet. So for the availability zone here, click on the drop down and select the first one here, the unit 1A. You click on it. So I set the IPv4 subnet slider to. So next I proceed to create a private subnet. So I scroll down and click add new subnet. So here I give the subnet a name, private subnet. For the availability zone here, I'll select the second one. So next I set the IPv4 subnet CIDR block to. So next I proceed to create subnets, click create subnet. So we've successfully created two subnets, a public subnet and a private subnet. So the next thing to do now is to modify this public subnet here to enable auto-assign public IP to automatically give new devices an internet address. So this will make them directly accessible online. So to click on public subnet here, actions, edit subnet settings. So here you can see auto assign IP settings here, enable auto assign public IPv4, click on it and proceed to save. So you've successfully changed subnet setting, enable auto assign public IP address. So next, we proceed to create a route table. We click on route table here. During the creation of the VPC, a route table was automatically created. So here I click on the route table that was created, click on this to edit the name. Let's say routes test. Sorry, public routes, and then click save. So a route table is like a map that tells traffic where to go inside your neighborhood. Without it, cars or data won't know which road to take. So remember we created two subnets, a public subnet and a private subnet, and VPC generated a route and we named it public route. So we proceed to create another route for the private subnet. So click on create route here, give the route a name, route, private route. So next, click on select VPC here, select the VPC that we created and create route table. So route table created. So go back to route table here, click on route table. Here you can see the two route tables here, the public route table and the private route table. So it's very necessary to give the route tables unique names so you'll be able to differentiate them. So next we proceed to create an internet gateway. So click on internet gateway here. So this internet gateway here is like the main entrance gate of your neighborhood that is connecting your VPC to the outside world. Also to give our VPC internet access, we need an internet gateway. So click on create internet gateway here. Give the internet gateway a name. Let's say gateway admin, gateway admin. Next, create internet gateway. So we successfully created an internet gateway. Next, we attach to VPC. So we're trying to attach the internet gateway to a VPC. So here you select the VPC that we created and attach internet gateway. So internet gateway successfully attached to VPC. We need a route from our main route. So let's go back to the main route table here. Click on route table here. Select the public route here. Click on routes, edit routes, add a new route, set destination to be anywhere. So for the target here, we select internet gateway here. Click on internet gateway, select the internet gateway that was created and save changes. So this will allow traffic from our subnets to reach the internet. So the next thing we need to do now is to edit subnet association. So click on the route table here. Select the public route table, click on actions, edit subnet association, associate it with the public subnet and save association. So we do the same for the private routes here. Unclick the public route, click on actions, edit subnet association and associate to the private subnet and save association. So we proceed to create a NAT gateway here. So think of the NAT gateway as a secret tunnel that allows the private servers to go out but keeps them hidden from outside. So we click on NAT gateway here, create NAT gateway here, give the NAT gateway a name, say NAT admin. So here select the subnet, click on the drop down here and select the public subnet. So remember that NAT gateways always go with public subnet and that was why I chose the public subnet here. So next I leave the connectivity type here public. For the elastic IP allocation here I allocate elastic IP. So next I create NAT gateway. After creating a NAT gateway here, we need to go back to our route table to update route table for the private subnet. So click on route table here, click on route table, select the private route, click on routes, edit routes, add routes, set the destination to be anywhere. Click on this, select the NAT gateway. So here we select the NAT gateway that we created, NAT admin and save changes. So now our private network will have access to the internet. So next we proceed to security. Under the security here, AWS offers two security groups, the network ACLS here, which acts as a firewall that protects the subnet level, and the security group here that acts like a firewall that protects the instance level. So think of this security group here as the lock on your server's door. It actually controls who is allowed to come in and what kind of traffic can reach your instance. So we'll click on security group here to create a new security group. Next, click create security group. So here we'll give the security group a name. Let's say security security admin, security admin. So for the description here, we're going to allow SSH port 22 and all traffic. Not traffic. So here for the VPC here, click on the drop down menu and select the VPC that we created. So here we have to edit the inbound rules and the outbound rules. So the inbound rules here are also called ingress. They are traffics that are coming in. So while the outbound rules here are traffics that are leaving and they are called egress. So next I click add rule here. I'm going to add new rule. So the first rule I'll add for the inbound rule here is port 22, which is SSH. So I click on SSH here. So this SSH here will allow me to log into my server remotely. So for the source here, I click on the drop down here and select my IP address. I only allow my own IP address so that I'm the only person who can log in, which is a very good security practice. So if I left it open to everyone, let's say I click on the drop down here, select IPv4 anywhere. So if I left it open to everyone, hackers could try to invade. So by locking it to just me, I block all strangers at the door. So I click on it again and select my IP address. So next, I'll add a second rule. Second rule here is to allow all traffic. Select all traffic and destination anywhere. So normally for a web server, I'll just allow HTTP, which is port 80, or HTTPS port 443. So but for now, I'm allowing all traffic, and this is only for testing. So later I can change it to just HTTP, or HTTPS once the server is running. So and that is it for the inbound rules. So next I have the outbound rule here. By default, the outbound rule destination here is anywhere, which is fine since my server may need to download updates or connect out to the internet. So next I click create security group. So we've created a security group and we set two new rules, the inbound rules and the outbound rule. So next we proceed to create a network ACLS. So a network ACL acts as a firewall that protects the subnet. So here we'll create two NACLs, one for the public and one for the private subnet. So the reason we separate them is this: public subnets host resources that need internet access and must pull images or updates from the internet, while the private subnet hosts sensitive workloads that should never be exposed directly. Also, having two NACLs let us apply different security rules to each layer and also keep traffic tightly controlled. So to do that, we'll click create network ACL. So here we'll create a public NACL. So we'll name it public network. So next, select a VPC and then click create network ACL. So next, we edit the inbound rule and the outbound rule of the public network ACL that we created. So we'll click on the public network, click on inbound rules, edit inbound rules. The first rule we are going to add here is SSH port 22. So the source here is going to be our IP address. So add a second rule. And the second rule we are going to add there is to allow all traffic from anywhere, and then we'll click save changes. So that's it for the inbound rule. Next we proceed to edit the outbound. Click on outbound rule, edit outbound rule, add new rule. So the first rule we'll add here will allow all traffic, and click save changes. So after editing the inbound rule and the outbound rule of the network public network, we proceed to attach the public network with our subnet. So click on actions, edit subnet association, click on public subnet, and we associate it with our public NACL. So click on save changes. We have successfully updated our subnet association. So next we proceed to create a private NACL. So unclick the public network, click on create network ACL, give it a name, private network, attach our VPC and then create network ACL. So next we edit the inbound rule and the outbound rule of the private network. So click on the private network, inbound rule, edit inbound rule. And the first rule we are going to add is port SSH, which is port 22, which is SSH. So click on type, select SSH port 22. So the source is going to be our public subnet. So this ensures that the only way into the private instance is through the bastion host. So we don't really need to expose our SSH to the whole internet, making it far more secure. Click on notepad, copy the public subnet here, click on it, copy the public subnet and paste it here. Paste. So we'll add a second rule, and the second rule we'll add here is for 3306, which is my SQL. Click on it. So it's going to be our VPC cider. So go back to the notepad, copy the VPC cider link here, paste it, paste. So the reason for allowing my SQL Aurora database here to our VPC is to allow internet workloads like applications to communicate. So the next rule is to deny all traffic. So click on add new rule number, all traffic, and then select deny. So save changes. We successfully updated our end boundary for our private subnet. So next we click on add boundaries, edit add boundary. So the add boundary here will allow all traffic and then save changes. So next we associate our private network with our private subnet. So click on actions, edit subnet association, click on private subnet and save changes. So and that's it for our network ACLS. So next we proceed to our EC2 instance to launch an instance. Click on launch instance. We'll give our instance a name, web server. So select an image into. So for the instance type here, I'll leave it at T3 micro. So here we'll select an existing key pair here. Click on the drop down, select an existing key pair or proceed to create a new key pair. So click on create new key pair, give the key pair a name, say test key. So click create key pair. So next we edit the network settings, click the edit, select our VPC. So scroll down, click on select existing security group, click on the drop down, select the security group that you created and proceed to launch instance. Instance successfully initiated, we'll go back to our instance. So the instance we created is running, but the status check is showing initializing. So we need to wait for the status check to show 3/3 check pass before we continue. So we keep refreshing the page till the status check shows 3/3 pass. Okay, so the status check is showing 3/3 check pass. So click on it to launch an instance, connect. Okay, so we have successfully connected to the server and this shows that our setup is working. So after connecting to the public instance, we SSH into our public EC2. Then from there, we'll access the private EC2. So clear this, clear, and then we'll go back to our instance, click on connect, click on SSH here. So this is the SSH command that we are going to use to SSH into our public instance. Click on it, go back to our instance and then paste. So here it says permission denied public key. So this usually means our key file is missing or the permission is incorrect. So to troubleshoot this, so first check if the key is in our folder. So run ls, okay, ls sh. Okay, so from here you can see that the key pair we created is not here. So what we need to do is to recreate the key file. So we nano into it. So before we do that, go back to our download, open the key pair that we created. Okay, so we'll copy it, go back to our instance. So run nano, then key pair name. So key pair name is test key, nano test key pair, then click enter. So paste the file here, click on it and paste. So next click on Ctrl S, Y and enter. Next, we run ls again to check if it's there. So as you can see, the key pair is now in the server after using nano. So we confirm this by running los -lah. As you can see here, we have the key pair. So next, we set permissions on the key file. So we'll go back to our instance to copy the chmod code. Copy this and then paste it. And what this chmod does is it ensures that only us can read the file, which is required for AWS to allow SSH access. So now we can try connecting to the instance again. So we'll go back, copy the SSH command and paste it. Okay, then we'll click enter. Okay, so we are now connected to the private server. So the next thing we need to do now is to test communication inside our VPC. So we try pinging the private instance. While we do that, we need to go back to our instance to check if this IP address corresponds with the private IP. So we'll go back You can see here the private IP address here 192.168.10.6 corresponds with the IP address that we have here. So we'll copy it, so we'll use it to ping, go back to our instance and run API. This is showing that our network setup is working correctly. Our VPC is routing traffic as expected, and the security groups and NACLs are allowing controlled communication. Also, the public instance can securely reach the private instance using its private IP. So with this, we've successfully built a layered secure AWS environment where private resources can stay hidden from the internet, but can still be accessed safely through the public subnet. So finally, we just built a VPC with public and private subnets, route tables for traffic flow, internet gateway and NAT gateway for connectivity, security groups and network ACLs for layered protection, EC2 instance for communicating securely. So this is the foundation of AWS networking, and from here you can deploy a teacher application and databases or scale secure workloads all inside your own private cloud. Okay, so and that's it. We've built a secure AWS VPC from scratch.